Hello and welcome to the CAM series for Project 1. My name is Stephen Thompson and this is CNC Beginner's Guide. Now in this video we're going to be going over how to make a setup for Project 1. In the last video we went over how to create a 3D model of Project 1 based on a 2D dimension drawing. And now we're going to start to think about how to make this thing on a CNC machine, and the first place to start is the setup. So why don't we get started. Alright, so here is Project 1, the 3D model of Project 1. And the first thing I'm going to do is I'm going to check my units. So in the browser bar on the left here, under Units, you can click that next to Change Active Units, and you can change it between millimeters and inches. I like to work in the same units as the tooling is. In this case, all of our tools are in inches because I'm using the sample library from the book. And then we'll go with inches. It's just easier that way. But you could work in either way. The important thing is to make sure that before you send it to a CNC machine, you know the units the CNC machine is going to be expecting. Okay, so before we get into how to create the setup for this, we kind of need to, spend some time looking at it and thinking how we're going to make it. Because really the first step is creating a setup, but the first step in figuring out how you're going to machine something is actually coming up with a machining strategy. Now, machining strategies are, widely variable, depends on your experience and your skills. And as you do more CNC programming, you'll get better at figuring out what the right strategy is. So kind of like where to start, what size the material should be, where the model should be in the material, what tools to use and what order using which tool paths. That's kind of your strategy. And, the one that we're going to be going over in this series is just my strategy for this part. There are many ways to machine this part, and I'm doing it in a way that I think makes the most sense for me, but it might be different and somebody else might even have a better way of doing it. Okay, so with that being said, let's just kind of get started by making a new setup. So to make a new setup, go to Setup and New Setup. Okay, so all of the settings that you can change and that you'll need in order to get this setup correct are in the setup dialog box. And what the setup basically is like all the initial conditions of your machining situation. It is like which object is going to be machined, what is the stock size, where is the model inside of the stock, where's the origin system, where's the work coordinate system, and like which direction is Z and X and Y pointing, and all that kind of stuff is going to be defined in the setup here. So let's take a look at this setup dialog box. So there's 3 tabs: Setup, Stock, and Post Process. In the Setup tab, we have these different sections here. So we'll start from the top and work our way down. There's Machine. So you do not need to select a machine, and we are not actually going to select a machine. That's kind of a more advanced option here. What a machine will do is actually, if you want to, if you click on it, there are 3D models of machines, and there's even a big Fusion library with a bunch of different machine manufacturers. And if you find your machine, you can add it in here, but it's a bit more complex because you have to double check the kinematics and make sure that the model that you download actually matches the capabilities and function of your machine. And then it gets a little more complicated after that because you have to be able to place your material in some kind of vise and then get that on the machine. And there's a bunch of steps to get it kind of in that correct position. And really what we're focusing on here is just kind of like basic skills for programming. And it's not necessary to have a machine selected. It can help in the simulation, but for most of the CNC programming that I do not select a machine. Because it just makes it more complicated, and I can actually get the toolpaths that I need without selecting a machine. Sometimes, especially when you're doing multi-axis stuff, 5-axis stuff, it's really important, and if not totally necessary, to have a machine selected so you can make sure that you don't get collisions because there's a lot more moving parts. So that's the machine. We're going to leave that unselected for now. under operation type, we want milling because we're going to be programming for a CNC mill. And the next is a work coordinate system. So the work coordinate system is a coordinate system that exists on your part in your CAM program. And it is it kind of lets the program know how the machine that you're going to use orients its coordinate systems in space. So you have to know, before you go to use a machine, you have to know how that machine orients its coordinate system before you can set it in here and program it. With most machines, not all machines, but with most machines, when you're standing at the front of the machine looking in, positive X points to the right, positive Y points away from you, and positive Z points up. So we're going to go with that. So right here is different ways of kind of adjusting the work coordinate system based on how your machine setup is. So under orientation, I'm going to change it to Z-axis plane and X-axis. So that means I can define the orientation of this coordinate system by specifying where Z is and where X is. Notice that it's now prompting me to set Z. So I can either select a plane and it'll be perpendicular to that plane, or I can select a line, any vertical line, and it'll be along that line. So I'm going to select this line right here. Z actually points along that line, but points in the wrong direction. So I want Z to point up. I can do that by either clicking the Z arrow and flipping it, boom, like that, or there's a flip Z axis button right over here in the setup dialog box. Okay. And now it's prompting me for X. It's saying which direction is X. And actually, if I'm imagining the machine in front of me, I'm imagining X pointing to the right like it is shown here, right? If maybe I wanted to machine this in this direction for some reason, I would have to flip X by clicking the arrow and flipping X in the other direction, and then it would machine it like this. And either way works, but I'm going to flip it the other direction so that you have the hole on the right here, and that's the direction that X arrow is pointing in. So that means positive X is to the right, positive Y is away from us, and positive Z is up. Okay, so I got the orientation correct. So the orientation in here has to match the orientation of the coordinate system in your machine. And that doesn't change. The orientation of the coordinate system in your machine doesn't change. You can change this one to match it. The other thing we need to do is select the location of the work coordinate system. And this is really important because the location of the work coordinate system is going to be where you tell the machine to start. And different machines have different ways of finding this point. So depending on how your machine is set up, it might make sense to select a different point. So let's see if we go to stock point here. Right next to stock point says box point. I'm going to click box point, and all these little points show up. And if I select a point, it moves the coordinate system to that point. And what that basically means is that if I set up my program starting at the top left corner, then when I get to the machine, what I have to do is tell the machine where the top left corner of my stock is. And on some machines, they have work probes. So it's kind of digital probe that can actually go around and find these points very accurately. Some machines you have to use like an edge finder. There are different ways of doing it. It really depends on your setup. So I know that the machine that I'm going to machine on has a probe, and it can find X, Y, and Z using the probe, and it can find the center of the top of the part. So I'm going to put mine at the center top of my part. It doesn't really matter which one you choose as long as you know when you go to the machine, when you put the stock on, that's the one you show the machine. And it really depends on kind of what your machine's good at finding, which points your machine's good at finding. Okay, so that's kind of basically work coordinate systems. It can get more complicated, but that's all you need to know to get started. The next thing down here in the model section is the model. So if you click on it, it says body because it figures that the only body in this file here. If you look down here, it's the only actual object in this 3D file. It assumes that that's what you want to machine. But if you click an X, it'll deselect it. So sometimes this is good because sometimes you're machining something that exists in like an assembly, and you want to like just machine this and not the other parts. Then you can say, okay, select that. But it's really important that right here that something is selected, and the thing that's selected is what you're going to machine. So make sure that that body is the selected body. The next thing is the fixture. So if you click on fixture right here, what the fixture is the work holding, or like, so like the vise, or it's usually a vise, but it could be clamps or something like that as well. This is a way for you to specify here in this part what is going to be machined and what should be avoided, or what, if it's touched by a tool, should be considered a collision. You can have your vise in here, and there are ways of doing that, and we'll have videos on how to put these projects in vices if you want, because it can be really good to see where the tools are in relation to the vise. One of the big things that's hard to one of the things to be really careful about when you're CNC programming is making sure you don't get collisions. Collisions are bad for a lot of reasons. You can eject things from the machine, you can break tools or like dull tools. We just want to avoid collisions at all cost. And if you don't set things up right, you can get a collision. So if like my vise is actually holding this part in the wrong place, I could get a collision. So sometimes it's nice to have the vise in the model, but it makes it a little more complicated. Fusion does, if you open the data panel, Fusion, if you go to cam samples on the left side here, we can see that Fusion has some work holding templates, different vices. So, if you find your vise in here, that's great, and you can use it. You'd have to I think save it into your Fusion and then use it that way. But it's something we'll go over in another video. It's not entirely necessary every time to have the fixture in and specify what the fixture is. It just helps. It helps you avoid collisions. So it can be useful, but not necessary. So we're not going to do it right now because it just makes it a little more complicated. Okay, the next thing we're going to do is we're going to go to the stock tab. So if we click on the stock tab, this is where I specify the size of the starting material, which we call the stock. So it's like the block of metal or whatever it is that we're going to be machining this out of. And I also specify the position of the model inside of that stock material, like where the model is relative to the sides. Okay, so under the mode, we have these different modes: relative size box, relative size cylinder, fixed size box. Depending on whatever your situation is, you might choose different ones. We're going to go with fixed size box. Okay, now I can't just put any number in here. I can only put numbers in here of material that I have available to make this out of. And what we're going to make this out of is 1x1 solid bar stock aluminum. So what that means is that in this case, the Y dimension is left to right dimension here. Actually, I can get a side view of it here. The left to right dimension, the Y, is going to be 2. And the up down Z is also going to be 2. Or sorry, it's going to be 1. Those are both going to be 1 because it's going to be 1x1 bar stock. And then the length is going to be something that's a little bit more than 2 actually, because we notice that you can kind of see a little bit here. The model is 2 inches wide, and right now my width X is 2 inches, and you always want a little bit more material than your actual object is, so you can kind of machine it away and get all of your sides freshly machined. Okay, so what we're going to do is depth of Y is 1. It's already like that. That's good. It just kind of guesses based on your model. It guessed pretty good. Height is Z is going to be 1. And width, since the model is 2 inches wide, let's make the stock something like 2.25 inches wide. And that is probably enough. Yeah, it's probably enough. In some cases, that might be too much. You want to get it a little bit smaller. But I think that for us, that's probably fine. Okay, so that's the size of it. Now the position of the model within the stock, really important. So if I take a look from the top, I have my X position, and I can see here width X, model position is centered. That's good. I want it in the middle in X. And in Y, looks like model position is also centered, which is also good because that means it's kind of like furthest away from those walls. But if we look at Z, take a look at the side here. If we look at Z, it's right in the middle in Z. And that may seem okay, but actually, I know that I'm going to be holding this piece of material from the bottom with a vise. And that means I'm going to want as much clearance as I can have on the bottom here. So what I mean by that is like the distance between the tool when it goes down and machines this thing and where the vise is holding on to it. I want as much kind of distance there as possible just to make it safe so I can avoid collisions. So one of the ways to do that is to move this up. So I'm going to go from Z, under Z here, model position, offset from top, and I'm going to change the offset to something like 0.05. So that's 50 thou off the top. And that leaves enough room to machine some material off the top and get a nice top, cleaned machine top surface up there, but then also more room on the bottom to hold it. And this is just because I'm holding this in a vise, and this is kind of like my method and strategy for that. If you have a different work holding situation, it might be different. You might make different choices here. But considering what I'm doing, this is the best choice for me. Okay, next is the post-process tab. So here we give it a program name or number. I like to just give mine basically the same name. I start with, if I'm working on a program, 1001. If I have a second setup or a third setup, I do 1002, 1003. You can't just put whatever you want here, only because certain machines only want the name in a certain format. So for some machines, you could write words here. You could say, oh, Project 1 CNC Beginner's Guide, Setup 1. But for different machines, maybe they just want a 4-digit number or a 6-digit number. It really depends on your machine. So check with your machine, see what kind of file names or program names it can take. But I'm just going to start with 1001. Under program comment, you can write whatever you want here because it's a comment. It's not actually going to be run in the code. Be run as a comment in the code. So we can see, I'm going to write